Okay, so let's continue with part B of benchmark 1 review. The solution to this equation. Well, before we start solving it, let's simplify it. Let's go ahead and multiply the 3 times the 4x. That gives us 12x. The 3 times the 2, that gives us 6. Then everything else I will just write down how it is. I can combine 2x terms. 12 of them plus 2 of them is 14 of them. I can combine a 6 and a 2. It gives me 8. Well, I have x terms on both sides of the equation. I need to have all of them on one side or the other. Let's leave the one that has the most. Let's leave those there. So let's subtract the 4x from each side. 14x minus 4x is 10x. So let's subtract, do the opposite of add 8, let's subtract 8 from each side. So 10x equals 17. 10 times x, well the opposite of multiply by 10 is divide by 10. So x is equal to 1.7. Oops. Bobby has a sister named Abby. Bobby's sister, Abby, is 4 years younger than half Bobby's age. Find Bobby's age if Abby is 3 years old. So let's write half of Bobby's age. Let's have B represent his age. Looks kind of like a 13. Okay, and then 4 years younger than that. So let's take away 4 years from that. And we know that that will be equal to 3. So let's solve that. Let's add 4 to each side. So half of Bobby's age is 7, so his age must be 14. Or you can just say, well, the opposite of divide by 2 is multiply by 2. Half of 2 is 1. 1 times B is just B. Bobby is 14 years old. Bobby collected plastic drink bottles and cans that could be recycled to raise money for his school. A recycled depot paid him 4 cents per can and 9 cents per plastic bottle that he brought in. If he raised over $77, what is the minimum number of plastic bottles he collected if he only collected 460 cans? Well, we know that 0.04 times the number of cans plus 0.09 times the number of bottles. Well, not equal to, but greater than 77. We know the number of cans was 460, so 0.04 times 460 equals 0.09b. I mean, sorry. Plus 0.09b is greater than $77. 4 cents each at 460 cans is $18.40. Greater than $77. So let's subtract $18.40 from each side. And that gives us $58.60. So we know that 0.09 times the number of bottles is greater than $58.60. So if we do the opposite of multiply by 9 cents, we divide by 9 cents. Well, that says 651.1 is greater than oh, sorry, B is greater than 651.1. I only knew how to write. B is greater than 651.1. So 652 would be, because we know we don't want to round down because it has to be greater than $77. And so it's a little bit over $77. Stuart walked at a constant speed. The distance, D, he walked, is equal to S times T. So where S is the speed in miles per hour at which he walks, and T is the amount of time in hours he walks. If he walked 10 miles in 2 hours, so let's put in those values. So 10 equals S times 2. How many, his speed must have been what? Well, we'll divide by 2, and that says the speed is equal to 5. 5 miles per hour. A company had the following sales over the first 4 years of its existence. So in year 1, they had $106,000 profit or sales, $131,000, $156. So if I look at the difference, that's an increase of $25. That is also an increase of $25. So we know that it's increasing by $25 each year. T is going to represent the time. But we don't know how many, an equation to represent that would be $106 minus the 25 for our 0 point. So $106,000 minus 25 is $81. Well, $81,000, but that equation would give us these numbers. If I put in a 1, I'll get a 106. If I put in a 2, I'll get a 131. If I put in a 3 for the T, I'll get a 156, and so forth. A sequence is defined by the recursively by the rules below. The function evaluated at 1 is 8. The function evaluated at 2 is 4. The function evaluated at any number is the value of the function before it plus the value of the function 2 steps before it. So for the third one, for example, I would get the one before it is 4, and I add the one 2 steps before it is 8, so I add those together and I get 12. So let's keep going. For the fourth one, I would get the one before it is 12, and I add the one 2 steps before it, which was 4, and that gives me 16. And so now for the fifth one, I add the one before it, which is 16, and the one before that is 12, so that's going to be 28, and so forth. Looking at the data in the table, write the equation that created the table. Okay, so y increased from 2 to 5, x increased from 2 to 3. And so if we look at the increase in y, the increase of y from going from 2 to 5 is an increase of 3. The increase in x going from 2 to 3 is 1. So we know that y is changing 3 times as fast as x. But we don't know its starting value. But we could say y equals 3x plus some starting value and plug in values that we know. For example, 3 and 5. So 3 times x is 3 and y is 5. So 5 equals 9 plus some starting value. So if I subtract 9 from each side, I get a -4. So my starting value is -4.